So we've done law 1, we've done law 2. What about if we take something like this then, law 3? Let's take 3 squared and let's raise it to the power of 3. Okay, 3 squared and let's raise it to the power of 3. Okay, why? Okay. So yeah, so you're right, the law says, and some of you have met this law before, you should just multiply the 2 and the 3 together. But my question is still, why? Can you convince me why this makes sense? Absolutely right. So this literally means, raising to the power of 3, means take whatever you've got there and times it by itself 3 times. Okay, so this would literally mean you take 3 squared and you times it by itself 3 times. So you times it by 3 squared and you times it by 3 squared. Is that okay? And so how many groups of 3 have we got then? We've got 6 in total. Sorry, how many? Yeah, that's a bad question. If we take 3 squared times 3 squared times 3 squared, we're just falling back on law 1, right? We just add them together, so we just say that's the same as doing 3, 2 plus 2 plus 2, 3 to the power of 2 plus 2 plus 2, or same as saying 2 added to itself 3 times, times by 3. Is that clear? You sure? Yeah. Yeah, good, okay. So in general then, if we take A, and we raise it to the power of n, and then we take all of that and raise it to the power of m, what's that going to be equal to?
A to the power of
n multiplied by m. Yeah? Okay. And that's literally what we got for part 3. So for part 3, when we had y cubed, all raised to the power of 4, what's that going to be equal to? Y to the power of 3, all raised to the power of 4, according to this law, we should just multiply the powers together. Yeah. So it should be 12, right? Is that okay? Here's a question, because I can do a slight variation on this. What about if I take something like this? So this time we stick a 2 in front of the y. How does that change things? Are you sure? Good, because you've also got to distribute the power over the 2 as well. So this will be 2 to the power of 4, and then y to the power of 3, all raised to the power of 4. You happy with that? Okay, so this becomes then 16 y to the 12. Okay, so be careful there, it's not just 2 y to the 12, it's got to be 2 to the power of 4 y to the 12. Is that okay? Good, excellent, so that's law 3. Let's have a look at law 4. By the way, this kind of numbering of laws is completely arbitrary. You can do it in any order. I just think this is an order which makes sense. Okay? So, can I rub this off? Alright, let's have a look at law 4 then. Okay, what would this be equal to? 2 to the power of 1. 2. Why?
Because something to the power of 1 equals itself.
Why?
Because
that's just what you've learned, right? Okay, that's fair enough. That's fine. Can anybody convince me why?
Because it's just 1 time 2.
Okay, so if I wrote 2 squared down, then you're saying times 2 by itself twice, get 4. Right? And if I wrote 2 cubed down, times 2 by itself 3 times, that makes it great. 2 to the power of 1 just means take 2 and just leave it, like you just got 2, right? Okay, so that's actually law 4. Okay, law 4 basically says if you take any number and you raise it to the power of 1, that just gives you yourself back. Okay, it just gives you A back. Okay, let's quickly move on to law 5, which is a nice follow-on for this. What would 2 to the power of 0 be?
1.
Why? Why is 2 to the power of 0 1? There's a reason why I've written it like this. Okay? So let's have a look. You're happy we're decreasing the powers by 1 each time? Okay. Every time we decrease the power, so to get from 2 to the power of 3 to 2 to the power of 2, what are we doing on the right-hand side? Dividing by 2 in this case. And if I move from 2 to the power of 2 to 2 to the power of 1, we also divide by 2. So if I follow the pattern down, to move from 2 to the power of 1 to 2 to the power of 0, I should divide by 2. Well, what's 2 divided by 2? 1. Okay. So I can basically generalise this, that anything to the power of 0 is always equal to 1. So you can think about it as a to the power of 1, and then I have to divide that by a to get a to the power of 0, which should just always leave me with 1. Is it okay, Pascal?
Yes.
Good. So anything to the power of 0 is 1. Okay, so I think I've got a few examples in here. There you go, down the bottom there. A to the power of 0, that's just going to be 1. All good. Are there any questions so far? Good. Let's push ahead then. Well, why do I have to stop here? Why do I have to stop at 0? Why can't I move on to 2 to the power of negative 1?
1 divided 2.
Exactly. I've just got to follow the pattern down. I've got to take 1. I've got to divide it by 2. What do I get? A half. Okay. I'd prefer you to write it like this rather than 0.5 because it would make the pattern make sense a bit better. Okay. But that's fine. Okay. And then likewise, what would 2 to the power of negative 2 be?
1 divided 4.
Good. I've got to take half and divide it by 2 again. Okay, so what's half divided by 2? Quarter, right? What about 2 to the power of negative 3?
8. 1 divided 2.
Exactly. I've got to take that and divide it by 2 again, which would leave me with an 8. Right? Anybody noticing a pattern? What's the pattern? What do you notice the relationship is between 2 to the power of negative 1 and 2 to the power of positive 1? What's the relationship between 2 to the power of negative 2 and 2 to the power of positive 2? What's the relationship between 2 to the power of negative 3 and 2 to the power of positive 3? What's the relationship? Just tell me.
It is turned upside down.
Good. So it gets turned upside down. You happy? So 4 you can think of as 4 over 1. In fact, let me write this in. You can think about 4 as 4 over 1 if I wanted to write it as a fraction. Well, then 2 to the power of negative 2 will just mean flip it upside down. Yeah? Okay, so what would, here's my question, what would 2 to the power of negative 4 be?
1 over 16.
Good, because you know that 2 to the power of 4 is 16, which means 2 to the power of negative 4 will just be that thing flipped upside down. Okay? So in general then, if I take a and I raise it to a negative power, that must be the same as doing 1 over a raised to the power of positive n, to the positive power. Do you see that? Yeah? We all good? Megan, you're looking into space. You sure you're okay with this? Okay. So here's my question. I'll extend this. Let me rub this off. What if I gave you something like this then? What if I gave you something like 2/5 to the power of negative 2?
25 divided 4.
Good. Okay, so I had a few different things there. Okay, I think Vatican, you were going for the first, like the quickest one, which is great. Agnes, you were going for the 1 over. So let's stick with that because that's what we're doing over here, right? So this is the same as doing 1 over 2/5 to the positive power, which is 2. Okay. Do you see that? Okay. Now, what is 2/5 raised to the power of 2? Megan, don't hide from me. You're okay with this? What is 2/5 raised to the positive 2? Excellent. You just square the top, square the bottom. So if you get given a fraction, you raise it to a power. It's really straightforward. You just do that power on the numerator and denominator as well. Okay. Now, what is 1 divided by 4 over 25? Good. And you can think about this. 1 divided by 4 over 25. If you divide by a fraction, you should multiply by the reciprocal. So you get that. Is that okay? Now, if you looked at this quickly, the negative just means flip it upside down. It means reciprocate it. Okay? So if I flip this upside down, this should just become 5 over 2 raised to the positive power. And if I square that, I get 25. And if I square that, I get 4. Okay, so either method is fine. Either method is fine. I prefer this one because it's quicker, it's less thinking, don't have to think about dividing fractions, I just know it works, right? If you want to go through this, that's also totally fine as well. there any questions?
No.
Okay, good.